Method students. In this video we're going to go through a couple of questions where we find the equation of tangents and normals, but this time using the calculator, and you're going to see that calculator is definitely very handy when it comes to these sorts of questions. So example 1, this is from our notes. It said find the equation of the tangent to the curve y equals cos x at the point x equals pi on 2. So what you're looking for when you do these on the calculator, you've got to hit interactive and then calculation and then line. So interactive calculation line. And if it's the equation of a tangent line you're looking for, then you're going to hit tan line. And in here, where it asks for the expression, you type in the right-hand side of your equation, whatever it is that you're going to have to differentiate. So in this case, it's cos x. You don't have to type the y equals though. So cos x, the variable obviously is already x, so you'd only ever change that if you were putting in, like, say, cos of t. You would change that to t, but in most cases you just use x. And the point that we're differentiating, the point where our tangent touches the curve is at x equals pi on 2. And you only need to put in the x value of the point. All right, so that information there is enough to get the calculator to spit out our answer. So the equation of the tangent line is y equals negative x plus pi on 2. Now the calculator doesn't put y equals in front of it, so the only thing you've got to remember is to write that equation as an equation. So it's y equals negative x plus pi on 2. Okay, so that's our answer, right? That's the equation of the tangent line. And obviously a whole lot quicker if you're allowed to use your calculator than trying to do that by hand, because as we saw in the previous video, doing it by hand involves quite a lot of steps. Okay, example 2. Find the equation of the normal to the curve with equation y equals x cubed plus 2x squared at the point 1, 3. So back into our calculator, interactive calculation line, but this time we're using normal instead of tan line because we're trying to find the equation of a normal. So same deal, expression is just type in the right-hand side of your equation. Oops. The variable's still x. The point, again, remember we only need to put in the x coordinate. So we know that the point is 1, 3. The x coordinate's 1, so that's the thing we put in here. We hit OK, and the calculator spits out the equation for us, remembering we just need to put down the y equals. Okay, so yet again, a much more efficient way of doing things if you are allowed to use your calculator as opposed to having to do all that step by step by hand. Let's have a look at an exam question here where it's a little bit trickier, but we can still use these functions to help us out here. The question says the normal to the curve with equation y equals x to the power of 3 on 2 plus x at the point 4, 12 is parallel to the straight line with equation... Okay, so we've got to pick the right equation. We've got to pick the equation that's parallel to the normal to this curve. So let's start by working out what the normal to the curve is. And even though we only need to talk about gradient, we can still use this function to work out the equation of the normal. So it's interactive calculation line normal. The expression is x to the power of 3 on 2. So x to the power of 3 over 2. Just putting that in a fraction because it needs to recognize that that whole thing is the power. Plus x at the point 4, 12. So we're going to put in point 4 because we only need to put the x coordinate in there. We hit OK. So there's the equation of our normal, right? Which is y equals negative x on 4 plus 13. But as you can see, for this question, we actually only need the gradient of the normal. So we've just sort of identified the gradient as a negative 1/4. So what this means is, reading the question really carefully, we're asked to find the line that's parallel to the normal, which means it has the same gradient as this. So which of these equations has got a gradient of negative 1 on 4? This might just be better done without the calculator, just using a bit of inspecting each equation. With option B, you can see that if we subtracted the x to the right-hand side, we're going to get 4y equals negative x plus 7. And if you divide both sides by 4, well, option B is going to be the one that has a gradient of negative 4, because you're going to get y equals negative x on 4 plus 7 on 4. So arguably there, the calculator hasn't done the whole question for us, but it's been very helpful at the start, so we didn't have to do too much working to figure out the gradient of the normal. Really, in this question, the work was just in matching up the option that had the gradient of negative 1/4. So I hope that gives you a good idea of using your calculator to find equations of tangents and normals. Definitely a really handy feature. As I said at the start, just remember that when you have to write down the equation, make sure you put y equals, okay? Because if you don't put that y equals, you haven't put down an equation. Cheers.